Here is a float number, which is smaller than 1. Then it assumes that you want to have the explained variance. If you put in an integer number, let's say 40, it will reconstruct or construct a 40-dimensional subspace. The same argument. And that's amazing, actually, if you then here project, for example, the MNIST data, which is 784 dimensional, onto 2 dimensions. Actually, we would expect that some clusters are formed which represent actually these numbers. And we will see that PCA is not fully able to separate these clusters because it's fully linear. And we have here manifolds which cannot be unfolded linearly. So we have to go for other methods like MDS or TSNE to really separate these classes. And it can be seen later that by doing, for example, a projection onto a 2-dimensional data of the full 784-dimensional data set, using TSNE, we can fully separate this data. Meaning we can find a transformation from the images directly to 2 dimensions where we can separate 9 numbers. This is quite nice. Of course, these numbers are nicely centered, they're well prepared and so on. And in reality, you will get much different things because the scaling variance is not given and so you have to work a little bit more, like on the MNIST data set. Okay, I would say we make a break here. Are there some questions to the PCA? So what you have to take with you is, actually PCA is based on an eigenvalue, eigenvector decomposition of the covariance matrix. We select the k biggest eigenvectors and eigenvalues of the sorting such that the variance they explain, because the eigenvalues explain the variance of the data, the cumulated eigenvalues are such that I explain, for example, 90% of the variance. Or I just give the dimensionality. I say from my expert know-how, I want to project this to a 5-dimensional subspace. Finished. Yeah?
For the example we've seen before with the gray background, how many eigenvectors were used?
I think 40.
40
we can look at this curve here, this elbow curve actually, and 95. No, probably must be around 150. So it's not shown on the curve, but it's based on an MNIST data set. So if I give 95, I would end up probably with 150 dimensions. So it's not 700, but it's still 150. Okay, good. Yes. This we'll do after the break. Yes?
Maybe one more question. When we saw the S in the beginning,
yeah.
You said it's not linearly. Well, you can't do it with PCA, but I thought if you just take the 3rd dimension away, you have the S in the 2-dimensional space.
Right, from this side, right? Then you get actually an S, you're right. You would have it, but it turns out that PCA doesn't do it. It doesn't find this direction. Yeah. It could, in principle, yeah? But in a general case, it cannot. Okay, we'll see how PCA can be boosted up by a kernel method to also cope with such nonlinear matters. And that's the kernel case here. It's the next topic.